morning. Today we are going to learn about lines and planes and how they intersect. But before I start, I got a question from Melissa and I'm going to do it. It's question 11, page 469. The question says, determine the Cartesian equation of a plane containing point. So the plane contains points negative 1, 1, and 0, and perpendicular to the line joining point 1, 2, 1, and point 3, negative 2, and 0. The best thing, if you want to do something like this, try to imagine the picture. We have a plane. The plane contains this point, and at the same time, connecting the line makes a 90-degree with the line that connects these two points. Okay, that means this angle is 90 degrees. This is the line that connects the 2 points, and the plane is making 90 degrees on this line and contains this point. It is exactly like, let's say this is the plane and this is the point, and the line is going like this, making 90 degrees on the plane. So as I said yesterday, in order to find the equation of Cartesian equation of a plane, we need two things. One, point on the plane, and this is no problem, we have a point on the plane. And the second thing is normal vector, vector that makes 90 degrees on the plane. We don't have a normal vector direct, but we can get it because these 2 points form a normal vector to the plane. So if I say B and A, I can say that this vector AB or BA is a normal vector. It doesn't matter AB or BA. So I can get the components of the normal vector. It will be A minus B, so 1 minus 3 is negative 2, 2 minus negative 2 is 4, 1 minus 0 is 1. Now we have the coordinates of the normal vector. We can write the equation. So negative 2x plus 4y plus z plus d, which I don't know yet, equals 0. Now to find d, we're going to use the coordinates of the point. So I'm going to take x and put negative 1. I will substitute y with 1. I will substitute z with 0, and I will find d. 2 plus 4 plus d equals 0, so that makes d equal negative 6. We can write the equation now, negative 2x plus 4y plus z minus 6 equals 0, or any scalar multiple of this will work. So if you decided to multiply everything by negative 1, it will work. 2x minus 4y minus z plus 6. It is plus 6. It will be the equation of this plane. So this is the question you asked Melissa. I hope that I was able to answer it and you understand it. Now, today's lesson, we are going to talk about lines and planes. Lines and planes in 3D can make always one of these cases. intersect in a point, parallel, don't intersect at all. The last one is lying inside the plane. In here, we have one solution. It is this point, the point of intersection. In here, it has no solution. There is no points of intersection. In here, it has infinite solutions, which are all the points on the line. So actually, the equation of the line is the solution of this kind of case. So those are the three cases: one point of intersection, no intersection, infinite intersections, the line lies on the plane. Okay, now let us try to see how can we solve if we have a question that asks us to find the point of intersection or what kind of intersection plane has with a line. I will do a few examples for you so you can understand. Alright, example 1. Determine point of intersection, if any, between line, the equation of the line is 3, 1, and 2, plus s, negative 1, negative 4, and negative 8. And s, of course, any real number, as every time we change s, we get points on the line. And the plane pi that has a Cartesian equation 4x plus 2y minus z minus 8 equals 0, if any exists. So let us assume, if we have this, let's assume that we have this point of intersection. And the coordinates of this point, let's say A, B, and C. This point lies on the line and also lies on the plane. So if I put this for R, it will work fine. There will be one value S that will give us ABC, and if I put it here, it will give us 0, the coordinates of the point of intersection. So if I substitute it with this point in the equation of the plane, I will this point should give us 0 here. So 4a plus 2b minus c minus 8 equals 0. Now I need to solve for a, b, and c to find the solution, to find the coordinates of this point. There is a big problem with this. The problem is, in order to solve for 3 variables, the number of equation has to be 3 as well. The number of equation has to equal the number of unknowns, and this is not available here. So I cannot solve when it is like that, A, B, and C. I have to think of a way to reduce the number of variables. Yes, there is a way to reduce the number of variables. What is it? If I wrote this equation, now we know that A, B, and C is a point on the line, and that should equal 3, 1, and 2 plus S, negative 1, 4, negative 4, and negative 8. If I write this in parametric form, I separate the A, B, and C, I will have everything in terms of S. So A equal 3 minus S, B equal 1 minus 4S, and C equals 2 minus 8S. Now I have everything in terms of S. So I can go back to this equation and substitute for A, B, and C and have an equation with only one variable, which is S. So instead of A, I'll put 3 minus S. Instead of B, I'll put 1 minus 4S. Instead of C, I will put 2 minus 8S. And equal 0. Now the remaining work is algebra. I will expand this, get rid of the brackets, and combine like terms. So cancels out. Now I know S is 3, I can substitute back and find the coordinates of this point. So A will equal 0, B will equal, I substitute here, here, and here to get the coordinates of the point. B will equal 1 minus 12, which is negative 11, and C will equal 2 minus 24, which is negative 22, and this is the coordinates of this point. So the solution is 0, negative 11, negative 22. This is the coordinates of the point of intersection between this plane and this line. Okay, so this is example 1. Let's do example 2. Example 2 says determine the point of intersection between the line L, they give us the equation of the line, X, they give us the parametric form already done, they are nice, 2 plus 2t and z equal 9 plus 8t, and t can be any real number, and the plane pi is 2x minus 5y plus z minus 6 equals 0. Okay, now we know if there is any intersection, the point will be common in the line. Let's say the point is x, y, and z. The point will be common in the plane and the line. So I can use x, y, and z. Instead of that, I will put the parametric form of this point. So 2 plus t minus 5, 2 plus 2t, plus 9 plus 8t minus 6 equals 0. So 4 plus 2t minus 10 minus 10t plus 8 plus 8t minus 6 equals 0. 4 minus 10 is negative 14, and yes, negative 4 minus 10, no, 4 minus 10 is negative 6. Negative 6 and negative 6, that will be negative 12. So 2t and 8. So we have 0t equals, again, negative 6, so 12. Alright, what number when we multiply it by 0 will get 12? There is no number. So no solution. So what case is this? Is this case. The line is parallel to the plane, because I cannot find a parameter that will give us this point. Okay, so this is example 2. Okay, I think I don't have more time in this video, so I will continue in the next video. See you soon. Bye.